Hi everyone, welcome for this third episode of the Foundry Gauntlet Revision 1. This week we will cover the week 2, the naive submission, the subprocess submission, and without further ado, let's just jump right into it. So first thing I want to do is just launch the level so we can see what we are up against. This is an array of 2x2 of the previous week, the DLatche cell, and there is multiple things I want to show you today, some tips and tricks, and maybe something you don't know just yet. So firstly, because this is a naive submission, usually I use the previous week for subprocess submission. But for this run, because this is my user, I just want to show a really simple and naive submission, but from scratch. I will just reuse the winner from last week. So for this, we want the DLatche cell from the previous week. And for that, you can go on the leaderboard and rules, and you can see the best reveal in this section. So this is the winner of last week. Maybe I can copy image link. I should do something to click on it and just show it full screen. So this is the winner from last week. Really nice and neat solution for a DLatche cell, and with our two options, output enable and row call select, plus the write, obviously. One little trick, maybe you might not know that, but if you click on this, it will open inside the Steam overlay, but if you control click, it will open with the default web browser. So yeah, it's like LibreWolf, I think, for this computer. So I want to go and use that thing. How I do that? So you can use those HC drive. Those are special image with metadata that Archip can read. So you just need the link. So I will copy the link, and I'll go in the library, load that thing. So we'll detect the link, and it will find that if it is able to find metadata, and if it is able, we'll just show it here. And then if we go to the blueprint section, we see that our blueprint is installed now. You can even open it and edit it if you like that. But for this one, is quite already cool. We have everything. We have our label, and everything we need to plug that thing. So I want to go then in the gauntlet, open that level. Basically, for this level, what we need to have is 4 DLatche cell with a shared write, enable, and biting data bus and flag. So every write are going to every other cell. Enable is the same, and biting is exactly the same. And plus we have this simple 2-not gate 2-bit address decoder. So if we give this, we have like 4 address we can address with those. So we can address each column and each row. So it gives a total of 4 cells. So for now, I won't do that. I just want to do those 4 DLatche cells plugged together. So the basic stuff we can do is just using the blueprints we have. So we know gated DLatche, output enable, and column row select, and we can just, you know, paste it 4 times, and then we have our thing. There is a lot of a lot of labels. One thing you can do is you can just select this, and with the proper mode you can select this with like the rectangle, and then you press Ctrl to go extrude that rectangle, and if you remove probes you will remove all that, so it's quite useful. You can do Ctrl A as well, will be the same. I will just not do that. What I want to do is something a little bit more smarter, because let's say we have 4 or 8 or X number of bytes for the addresses. The DLatche cell will just, the quantity of it will just grow, and we don't want to paste that like a lot of time. 4 maybe is okay, but it can be kind of tricky to wire that up correctly without making any mistakes. So what I want to do is show you something else. I will hide the labels for now. With F8 you can cycle through UI elements, and you can remove what you want to remove. So right now I just want to remove the labels, so we can just see just the blocks. And I will just trim this a little bit down, like so. So we have a proper base to work with. And the new mode you can use to like basically replicate this DLatche cell we have is this mirror mode. So I will say pattern mode because it's the new name. I forgot to rename that. It's a mosaic mode, but if I reference that as mirror mode, mosaic mode, or pattern mode, it's all the same. It's the new experimental mode I want to try with this gauntlet. So basically you have 2 modes. You have the simple mirror or pattern or mosaic operation, which is quite simple. You just click on it and it will do a copy, and it will do that to the right of the current base. And if you click another time on copy, it will just copy the 2 and then the 8. So you can go quite wild with that. You can use those other modes as well. So mirror X, it will just flip on the on X axis. You can do mirror Z, so on the Z axis, the horizontal one. Radial is quite funny. It'll do symmetry from the center, but you need to have a proper base to make some use of that. Flip X and Z is like a complete rotation. And you have half, so quarter rotation. This will change the base as a square, and then it will put that square rotated clockwise or counterclockwise. So this is really basic for this mode, but we want 4 of them. So maybe we just want to click on that button and go on into advanced mode. So this mode is what we are looking for. So we want 4 cells. So right now you can change the grid size, you can go really crazy, but we want to, and we will fill that with copy for now. So we have 4, and we can just copy that, and it will do those copy just like that. what I want to try though is those other, so if you click on those cells you can change the mode of what the copy will look like. So for example, if we want to do an mirror X here and then a mirror Z here, like this, we'll have that. So right now it's not really practical. I will just fall back to the copy. Let's do that instead. And so now we have our 4 copy. So you must stop there and might be quite enough, but we have some issues. So for example, here everything is connected, so not great. Here everything is disconnected, so not great as well. So what you want to do is maybe add a space here for taking care of that side of the mirror. So now we have this space, but now we have 2 spaces instead of 1 because we just copying that thing and mirror it on the Z-axis, so it's not really nice. So what we can do is use the overlap mode, and when we do that, basically the first block around the template will be merged with the neighbor. So now you can see those one block is merged with every other copy. So that's quite useful, but right now everything is disconnected and I want to do something really simple. So my idea is to put that biting row in the middle, and this biting trace will be shared for those 4 DLatche. So right now I just will remove everything. You can also do that, restart level if there is label that stays there. Let's grab our blueprint again, and this copy we will flip on the Z axis with the Z button. And oh, it's okay for the input, we'll just do that, Z, and we'll just put that here. Okay, so this is the thing that is a little bit annoying with so many labels, but right now we need to align those so we are not confused with what is selected. So I want the enable to be aligned with this enable, so I'm taking this and I put that here. The right is here, so I want to align the right with that, and the row and column select are there, so I guess that's fine. We have already our 2 addresses, we can use that, and the biting needs to be there. And then I will just do some cleanup, so I will remove that, the right also. The row and col cell, I want to keep them just for clarity, because I have something in mind. I want to be reminded that those are the row select and column select. The biting is already the same, so we can just remove that. And on the other side we can use those as well, but let's do that right and bite out, and we have our row select that is not output for the level right now, but for what we have in mind, what I have in mind is okay. So we have our base. So now I want to do a proper mirror of 4 times that DLatche. So I will just remove a little bit of space here. I don't want any space here because remember I want to overlap on that line, so the byte-in will be shared. So with a copy on the right and 2 copy mirrored on the z-axis, we will have a nice and shared data bus. So that looks cool. So if I do that, you can see it's quite simple with that blueprint of the winner. It's quite easy, it's just a line, really compact and efficient, and we have our byte out. So that's cool, but maybe it's not enough because right now we have our 4 copy sharing the same data, but if we start the energy, nothing is plugged together. So maybe we want to refine our base a little bit more. So we'll just undo, and now I want to have all those cells sharing the data, the power lines. So I will do that here. Let's go that route. Now we want to route the 0 on this because the power rails are always at 8 for 1 and at 6 for 0. So I know this one is at 8. If you put your cursor on the left bottom of the screen, you can see the cursor here, and it says 6, so it's our power rail. But there is quite some stuff on the way. So if I do that and I select, you can see everything is selected now, so this is not what we want. So I will reroute that a little bit. Let's do this, top, this, and then we have this that can go, but here we have this connection, so we want to avoid that. And remember, it's a naive solution, I don't want to think too much about it, but of course there is some way better way to route them. And now I can join those. And because we are sharing the boundary of each template, this will connect to the other side, the bottom one, and this as well. So if we do our mirror operation and we start, we can see now that power is shared with the 2 first DLatche, but on the other side no connection are made. So we need to reroute this and this. So let's do that. So if you want to be really sure you don't mess, use the select segment to be sure you are extending the proper line. And I want this on 8. Okay, so we are there and we want this to be here. And now we want that. Can we go from there? I'm not sure I can go up. And we want to go 6. Okay, so we should connect with the other side. Okay, so now the power should be fine. So let's try that. Oh, and we have our first problem here. So we are connected onto something we shouldn't be connected to. So you can see here our connection between our 2 templates are really too close. And I don't want to take too much time fixing that. So I will just be simple. I will just extend that once, this there and there. So now we should be all set, and let's try once more. Great. So that looks like perfect. Just making sure everything is fine. And by the same token, if we want to push that a little bit further, we can go while we can just reapply that same thing again, and it should work. And we can apply that again, and it should work. Obviously, this works only for the power. All other flags and data are not shared properly, so we'll just go back on our base. And now we want to make sure the right is properly connected with everything else. So let's apply that. And let's see if I select this cube. So it seems that the line is properly connected horizontally. So that's great. Oh, what's this? Oh, it's fine. It's not great, but it's fine. The important is that the right here is connected to the right on the left. So those is just fine. If we do the same for the enable, we should be able to see the same pattern. And the enable is connected somehow to our power line. So how does that? Oh, see, this is this pot. So if we do that, we can see that that little angle touches the line. So I will just do that. And for good measure, I will just make sure those are routed like that, so might prevent some other accidents. Let's go a little bit more safe like that. We reapply. That looks cleaner. And now we can select our enable. Great. Enable is properly connected. But now we have the issue that we want the enable to be connected on the below side as well. So how we would that? So what we can do, we could go the way of putting a line this direction, or the other way, but I'm not sure I want to do that. Let's go crazy. I'll just do one row to route those properly. So here is our right, and this is our enable. And now we need to extend that and this. Of course, this is really like a limitation, because now this pattern won't work everywhere. But for this 2x2 it should work just fine. So now we are connected, and if I go there and select and once more we are connected to the power lines somehow. So how I do that? Oh, see, it's because of that. So what I would like to do instead is change our pattern. Maybe we can do X, so mirror X, and then flip on the both, flip Z and X. So let's try that. Yes. So the power should still be shared. Perfect. Now we want to try the enable. So enable is now connected, great. And we want to get the write. Write is connected as well, great. And we can verify our row, but this row is important because it must not be shared. This is the first row and the below one must be, so this is our second row, so we want to keep that. And we want now the column. So the column must be this. So the column must be in this direction and this direction. So we want to share that with the below one. So once more we can change a little bit our base, and I will do that, that, and that. And so I will be connected to the bottom one with this. So now if I do this, yeah, I should do that maybe. And so it's important to edit your base template, because on this side, it is done, because when it's not on the first line, all inputs will be removed. But on the other side, because it's just the first column of the die, it will replace with a metal block. But you know, for sake of completeness, we just will take care of that one with a normal block, so it passes the replication. So now if I apply that, I should have everything set up. My enable should be everywhere. My write should be everywhere. And it's quite simple to just test with a glance. It should have like this symmetrical shape. So if it's not perfectly symmetrical, you will see it really fast. And then we have our two column, and then we have our two rows. And if we launch, we have our power. We could even go as far, just do another copy of this. So because this is symmetrical, we can just do this, fill with copy, and then apply that. And I think this row, for example, if we select this, the entire line should be selected. Same here, same here. Maybe we have some trouble with this. We must refine our base to connect those two together. But I guess you are seeing what you can do with the base if you edit really well this first template. But we need just 4 DLatche for this one. So we will stop there. I will apply the first one. So it was mx z, mx, no, it's x and then z, and then we want a flip. So it's x and z. And I will apply that. And I will keep and work with that new base for this level, for this naive solution. Yes, so everything is fine, just check in. Okay, so we have our base, and now I just want to implement really simple 2-bit address decoder. So I won't try something too fancy. We'll see if the label will survive this operation, but let's just put not. This is the not. Maybe I want an inverter instead. Maybe not this one. This is a classical one. So I just want 2 of them. We'll put them this way. Okay, let's put them far away. And 2. So we are still good. I'll then extend that here. We want the enable to be here. You know what? I'll put that at the bottom, so it won't interfere with those. I'll just recreate those blocks. I'll extend this. And now we want those row select and column select to be plugged in. We want this to be powered up, and we can just do that. So our inverter are powered up as well, and then we can just plus that address. So you can spread out or spread in the space with the plus and minus key button on your D-pad. So this is a little bit too far. I will just put that here. Up. So now if we have this, we have our 2 row and column select. I will just remove that. So let's plug. We'll just assume this is the row select. The row select is the 3rd one. So if I look this correctly, this should be there. So I need to plug to this. So one of them will be connected here, and the other one simply will be connected there. We will try to make it work first try. And now we have the column we want to plug. So let's take this. So this is equivalent as the signal non-inverted. So let's plug that here. And then we have to look for the other. We might have to think. Oh, I'm sure you can see some. Let's remove. We don't even have space. This is a flaw, but you know what? We can make this work still. So if I do that, can reach here, no problem. Here I touch, so 2 up, 2 down, and then I go this. Just making sure I'm not touching anything else. And now we want to squeeze the signal here. I will connect if I do that, and I will connect if I do that. So you know what? We have some space. We will use the space. There. And basically what we want is this and this. Up. Quick and dirty. So now if I do this, I should have the entire row, first row selected. If I do this, second row. If I take the other address, this, it should select this entire column. And if I take this, it should select the first column. So that looks like something that could work. So if we look at this, we have some flag we need to carry, maybe for other cell, maybe, I don't know. But they should be already plugged in. So let's try the first test case. Seems to work so far. So this first test case is writing 0 and read 0 from address 0. You can use this quite handy show change indicators. So we will see how this behaves. I will just reduce that a bit. And maybe this, because we just want the first phases. So here we are writing 0 byting into address 0. So it should be written right now. If I do this, it clears any flag, so no enable, no write. It maintains the data on the byte in, so the cell is sure to have that value until the flag are cleared. And then if we enable our bit in, which is just the data bus, and if I select properly, yes, will be our byte out. And you can see now that this block doesn't feed source any values, like this byte in should be at neutral, but still our output has value, and it's the cell, the DLatche cell that is providing this value. And if we clear the flag for the next step, it just works. So I have high expectation for this to work first try. So you know what, I will put that here. Let's put this here and launch the validation. So power up, write, clear, read, clear, write address 1, clear, read. It's going well. So the first few 4 phases are writing value into each cells and reading back from it. The phase 4 will read each cells to verify that you still have the proper value. Let's remove the change indicator. And the phase 5 through 8 will just write the opposite value and read it back again. Those has no checks. And What you just saw is a special thing because this is a cheesable level. So the last step is just randomizing each phase and testing that you are not making an ASIC that just responds perfectly to those inputs. And like that, we just add our 2x2 1-bit gated DLatche working, and I just did really a nice increment from the previous submission, and I'm sure you can see a lot of other improvement you can do, like maybe this side can be made a little bit better, but you know, I think I got through the idea I wanted to share you guys is how to use that mirror operation properly. And with that I will stop because it's already 40 minutes and that's already a very long video. So thank you for watching and see you on the leaderboard.